So, as there are no questions at this moment, thank you so much, sir. Now, let's move to next keynote profile, Mr. Satyabrata Pradhan, an automotive engineer and program leader and an IEEE senior member. Mr. Pradhan is a software defined mobility specialist with expertise in software defined vehicles, artificial intelligence in automotive validation and testing, cybersecurity for connected vehicles, automation, and embedded system. With that, let us warmly welcome Mr. Pradhan.
Can you guys hear me now?
Yes, sir.
Okay, thank you. Let me share my screen. Hopefully, you guys can see my screen now.
Yes, sir.
Okay. Oops. Okay, so let me go ahead and start. So, yeah, thank you all for giving me the opportunity to speak about software-defined vehicles and AI-defined vehicles now, as we are evolving from normal vehicles to the automotive vehicles, like the software-defined vehicles and artificial intelligence-defined vehicles. Hopefully, my research will give some ideas about how the world of artificial intelligence is getting changed. Um, yeah, as I mentioning, over the next few minutes, I will be exploring how artificial intelligence is becoming the core decision-making engine in modern vehicles, the advantages this brings, the challenges we must overcome, and the most importantly, how the transformation will create safer and more efficient transportation for everyone. Let's begin the topic. Uh, we will be talking about how the automotive paradigm shift is happening. Currently, if you guys all know, we have currently on the traditional vehicle sections. Where the traditional vehicles are mostly hardware centric machines. Most of the vehicles we have right now, predominantly those are mechanical system with so much of miles of wiring, some limited electronics and fixed limited electronics, and these are fixed functionally. What you brought was what you got for the vehicle's lifetime. Means if you don't want to do any changes to your vehicle, you will be staying with that all the time. The software defined vehicle era, which started close to 3 to 4 years back, um, introduced a programmable feature over the air updates, the modular architectures. Uh, Tesla has started pioneering that approach, showing the vehicles could improve after the purchase of the software updates. Like if you want to go with the fully automated autopilot or fully automated the enhanced driving, that helps. Like the Tesla did that through the over the air updates. They used to update everybody to have um, like FST full self-driving. And but now we are entering into AI defined vehicle era, as per recently uh, recently described in the consumer electronics conference at Las Vegas, where AI will be becoming the central to the vehicle operation. This artificial intelligence defined vehicle systems features notorious continuous learning, automation, decision makings, and predictive capabilities that fundamentally change the vehicle's relationship with the drivers and the environment. This is the frontier we are exploring today. Let's coming to the next slide. The foundations. We'll be talking about the foundations of the software-defined vehicles. Before driving into the AI-defined vehicles, we must understand the foundation of the current generation of the software-defined vehicle architecture. So SDV rests on these particular four key pillars. The first one is a centralized computing platform, which is replacing the distributed electronics control units of traditional vehicles. For each of the in traditional vehicles, you will see like there are like thousands of electronics control units. So in the software-defined vehicles, instead of having thousands of separate computers, there will be a high-performance processor which will provide the unified vehicle control, and it will also dramatically reduce the hardware complexity. Second, the modular software stack enables service-oriented architecture where features can be independently developed and deployed through standardized APIs, similar to how apps working on the smartphone. Third, over-the-air updates, which allows continuous improvement, bug fixes, new feature deployment without requiring dealership visits. You don't have to go to dealership to update your infotainment screen. You don't have to go to dealership to update your body control module. So this current keeps the vehicles current throughout their life cycle. So you'll be having over there up to dates all the time. If there is any issue happens with your vehicle software, that can be automated automatically. Finally, there is comprehensive data collections infrastructure through the sensor network and telemetry system that gathers operational data and analytics and diagnostics. The data foundation become crucial for the AI systems. These four elements create the platform which AI can flourish. Let's go to the next one. So now this comes the new AI-defined vehicles, the intelligent evolution. Now let's examine what makes the AI-defined vehicles fundamentally different from their software-defined vehicles. So as you see, the AI-defined vehicles presents a paradigm shift where the artificial intelligence become the core decision-making engine. We are moving to programmable machines to learning adaptive systems that improve autonomously. There are three different key differentiators which I think that will be define the evolution. The first is the cognitive computing through neural networks and deep learning that enables human-like perception and decision making. The vehicle doesn't execute pre-programmed rules; it understands the context. Second, the autonomous adaptation allows the system to self-optimize based on the driving patterns, environmental condition, and individual user preferences without explicit programming. Basically, it will have a um, like we have a numerous amount of data available, and we will be using from there to create our data patterns. Third will be the predictive intelligence, means AI models can forecast maintenance need, predict potential hazards before even they occur, and even anticipate driver intentions. The chart on the right quantifies these leaps across all the key matrices: adaptability, autonomy, and intelligence and efficiency. The AIDV system shows how dramatic improvement it is happening from SDV to AIDV, with intelligence capabilities nearing doubling every time. This is not incremental improvement. It will definitely take some time. It will have a transformational change. Uh, so let's talk about the core technologies. AI technology will be in the AIDV. Basically, I think these are the six different portions which will bring some transformation to the AI technologies. Like you all know, computer vision, which is mostly required for the active safety or the ADAS systems, or the I will say like the full self-driving modes. Computer visions providing the real-time object detections, lane recognition, and scene understanding using the conventional neural networks. The vehicle sees and interprets its environment like a human driver, but more like it can also predict what will be the next outcomes. Sensor fusion AI that integrates multimodal data from cameras, lidar, and radar to create comprehensive 360-degree awareness. far exceeding human perception capabilities. Natural language processing powers, voice control, and conversational interfaces using transformer models, making human vehicle interaction intuitive and natural. So, this is how, like, it's a normal, like, if you are using the speech processing, it will be using a human interaction, and it can get you the proper informations. Reinforcement learning enables the continuous improvement of the driving strategies through trial and feedback, allowing the vehicle to optimize its behavior. Like currently, the AI has a vast data available. So once you have a lot of people's driving strategies are available to them, they will be optimizing the behavior all over the time. Edge AI computing performs on device interface with optimized neural networks for low latency decisions, critical when the milliseconds matter for safety. Like every time, we not only for us, it has to think about the other people also. So each millisecond matters every time. So the edge AI computing will help us to do the critical analysis and help it for the safety of the everybody. Finally, the federated learning enables privacy preserving and distributed training across the entire vehicle fleets. So each vehicle benefits from collective experience without compromising the individual data privacy. Together, these technology create an intelligence ecosystem greater than the sum of its parts. So let's moving to the what are the advantages from compared to the STV to the AIDV. Let's examine or investigate few of the advantages from the software-defined vehicles to the AI-defined vehicles. I will say the enhanced safety will be the paramount for this. AI-powered predictive collisions avoidance systems, it will be reducing the accidents up to 40% compared to the conventional STV system. That was my research, which says it's a 40%, but throughout, if we have this AIDV and uh, we have a lot of data available to driving data available, it may even increase to 60%. The AI will not, it will not just react to the hazards, it will also predict and prevent them. The personalized experience. The personalized experience means the machine learning will adapt to every aspect. So whether it's a teen driver, whether it's a adult driver, whether it's a senior citizen who is driving, it will adapt to every aspect. It will driving dynamics. It will climate control, infotainment to individual preference. If somebody is sitting on the rear seat, they can have different infotainment compared to the someone is sitting on the driver or passenger seat. It will add up to each individual preferences, learning and improve continuously. Predictive maintenance, which represents a major cost saving. Deep learning models will predict components failure 7 to 10 days in advance, reducing the downtime by 35% and preventing expensive emergencies repair. So we can if your there is a chance of your engine oil is going to get low, we can predict that future compare, and like it can set up your auto like service repair and everything, and you can reduce those downtimes. Energy optimization through AI driven and power management improves range efficiency by 10 to 20% through our intelligence route planning and behavior analysis, which are crucial for the electric vehicle adaptation. It will also look into your how you are braking, how is your driving patterns, how speed you are driving, and then it will look into which are the best routes for you to go. So which will save the range efficiency when it is an electric vehicle. Finally, the continuous improvement via the fleet learning enables the rapid capability upgrades without any hardware change. Every AIDV will benefit from the experiences across the entire fleet, accelerating the innovation. Maybe these are not theoretical benefits. The early deployments are already demonstrating these improvements in real world conditions. Like you can see, like how the Chat GPT or the Gemini, they are improving. In the same way, I feel like the SDB to AI transition will improve our vehicle efficiency and everything. Moving to the next slide. Sorry. Um, we're talking about the safety of the sorry, I think I missed the challenges. Yep. So let's talk about the challenges which are coming into the picture. I feel like the computational demanding will be a big challenge, because it's we need more processing power, we need more coolant agents, and we need hardware upgrades, and on top of that, more powerful onboard computers. I think NVIDIA and other companies are the micro developer companies are working on that one. Data privacy and the security concern also, there is a big chance we need to focus on. The data privacy and security concerns are amplified because the AI DV systems require continuous data collections. So there is the biggest vulnerability you can find, and it can also question about user privacy. Regularity uncertainty presents a major hurdle. Also, we lack standardized frameworks for AI decision making liabilities, validation testing procedure, and safety certification. When an AI makes a mistake, who will be the responsible? Whether it's the governing body, whether it will be the federal government, whether it will be the person who is developing this, who will be responsible for this one? That's the biggest question. Also, model reliability remains a challenge. Edge cases and adversarial scenarios can be unpredictable AI behaviors, which requires extensive testing far beyond what traditional software needs. Finally, the infrastructure requirement, which includes high bandwidth connectivity for real time updates and substantial cloud computing resources for training sophisticated models. Like if you are in a rural area and you don't have any internet connections, that may be very difficult to get into. Like your vehicle and getting into the cloud, and you're getting into the real time updates. So addressing these challenges will be requiring collaboration among automakers, technology companies, regulators, academias, and none of them will be coming are insurmountable, but they demand serious attention. Coming to the next, where the safety advancements we have, these are the key safety capabilities. I feel like the uh, 5 key safety capabilities. I feel the predictive hazard detection, which allows AI to analyze the traffic patterns like few milliseconds faster than the human reaction time. Because for us, we see it, then we react through our brain. That takes a time, but that will be not the same thing for AI. It will be immediately reacting. That like it will be even also is a predictive reaction, that is through the prevent to enough to prevent the countless accidents. Multi-agent coordination through vehicle to everything communication, which enables AI traffic, power traffic flow optimization, and the vehicles where the vehicles will be cooperatively navigating complex scenarios. Behavioral anomaly detection identifies the distracted and impaired driver in the vicinity, allowing the vehicles to compensate with more defensive driving strategies. Adaptive safety systems provides real-time adjustment and of braking forces and steering responses based on road condition, whether it's a icy, whether it's a uneven surface or weight. Emergency response AI drivers delivers autonomous crashes avoidance and optimal trajectory planning in split-second scenarios where human drivers simply cannot react fast enough. So, if I see the statistics, there is a chance of 40% accident reduction, which is a great thing actually. 62% fatality prevention and 3.2 faster better response time, which will, and 99.7% pedestrian detection accuracy. These numbers just representing more than thousands of lives saving annually. This analogy justifies AI can transform what we're talking about. Moving to the new will be the future outlook of the AIDV, advanced AIDV capabilities. We can so it will it if we integrate the AIDV, there is a chance we can achieve the full autonomy in SA level 5, which like means driverless operation in all condition, urban, rural, highway, or any other. This includes also complex urban navigation, human AI collaboration, control for smooth transitions, critically embedded ethical discussions, frameworks for unavoidable accident scenarios. Collective intelligence presents a paradigm shift from individual vehicles to the interconnected swarms, fleet-wide fleet-wide learning network means every vehicle experience improve their entire fleet. Distributed decision making enables vehicles to cooperatively solve traffic challenges. Then smart city integration will optimize traffic flow at every level. Then predictive ecosystem will transform how we think about the vehicles. Intent prediction system will anticipate where you want to go before you say it. Proactive safety intervention will prevent accidents before the hazards fully develop. Contextual route planning will optimize your schedule preferences and real-time conditions. Life cycle cost optimization will minimize the total ownership expenses. As you all know, that this is like the uh, maintenance fee is a big amount for owning a different vehicle, so this will reduce the ownership expenses also. Expected deployment time frame will be, I feel like 2027 to 2030 will be the for the level 4. Then 2032 or beyond it will be true level 5 autonomy. We are working on the cost of this transformation. Finally, I come to the conclusion. The transition from the software-defined vehicles to the AI-defined vehicles represents more than a technological upgrade. It marks a fundamental reimaging of the automotive intelligence. AIDV systems will offer unprecedented safety through the predictive capabilities that prevent accidents before they occur. They deliver superior efficiency through intelligence optimization of every vehicle system, and they provide enhanced user experience through personalization that learns and adapts continuously. This transformation is powered by cognitive computing, predictive analytics, and continuous learning capabilities impossible with conventional software approaches. However, realizing this vision requires key five imperative from our industry. First, invest in AI infrastructure. We need to focus on more AI infrastructure, the hardware and the software foundations. Second, establish a clearly regulatory framework for AI decision making liabilities. Third, prioritize the cybersecurity to protect these uh, increasingly connected data driven systems. And then fourth, we have to enable collaborative development across entire automotive ecosystem. It's not only one or two companies, everybody has to come together to have this ecosystem achieved. And fifth, the maintaining a high centric design, human centric design, where AI should augment human capabilities but not replace the human judgment. The AI defined vehicles future is not a question of it right now, but when the question um, before us is, we will set this future proactively or react to it. Thank you. That's all about my research paper. Thank you all. Are there any questions?
Thank you so much, Mr. Pradhan, for your insightful presentation. If anyone has any question, they can raise their hand. As there are no question at this moment, thank you so much, sir.
Thank you.